Hello everyone, welcome to this tutorial on compound interest. What do we mean when we say compound interest? What we are trying to get at here is the value of the loan plus the interest when you go to pay it back. This could be computed over any period of time. What you have to do is consider the annual interest rate, the number of periods during the year that the interest will accrue or be paid out at. Now, in our first example, we are looking at how much we have to pay if we have a $200 loan for just 1 year, but it pays out at 8% interest, compounded quarterly. When we say quarterly, what we mean is that the interest is calculated 4 times in 1 year, 1/4 of a year each time. We know a quarter is 3 months, but you're going to do that 4 times over the year. So the number of periods in the year will be 4. N is going to equal 4. What's the future value of the loan? That simply means how much are we going to pay out at the end of the year for both the principal and the interest. If it was simple interest, we would take that $200 at 8% and we'd be done. But because the interest is paid out on the principal plus the interest as it accrues, we have to pay a different amount. So what's the formula? The formula we are going to be looking at is a future value is going to be the value of the amount times 1 plus the number of periods, I, the interest, times the number of periods as your exponent factor. What is I? I has to be broken down to the interest per period. So if it's 8% for every year, and there are 4 pay periods, it compounds quarterly. That means your interest is 8/4, right? Which is equal to 0.02. So our formula becomes future value equals the face value amount of 200 times 1 plus the interest, 0.08, divided by n, the number of periods, times the time up here, which is 4. All right, what does this come out to? It comes out to being 200 times 1 plus 0.02 to the power of 4. What does all of that equal? It comes out to be $216.49. Because you multiply 200 times 1.02 to the power of 4. That is equal to 1.02 times itself 4 times. So we could have said 200 times 1.0824. That's going to give us $216.49. So that's the principal and interest. If I wanted to find out how much the interest was, I would simply take off the $200 from here, the face value of the loan, and that would tell me how much interest I actually paid. There you go, $16.49 in interest. That was with compounding. If I had used simple interest, the amount of interest I would have paid over the year would have been 200 times 0.08, which is equal to 216. So you ask yourself, well, what's the big deal? Why would I bother doing this? $200 doesn't demonstrate much of a difference. It's 49 cents. But when you start talking thousands and hundreds of thousands of dollars, it's not pennies anymore. It becomes a significant amount, especially when it's over more than 1 year. It really can accumulate to a lot more. Okay, let's take another example in here. What happens when we have invested today $7,000 and in 6 years with 6% compounded semi-annually? What's the compounding frequency, the period interest rate, the number of periods, the present value? That's a lot of things to figure out. So let's try to break this down a bit. If we have the future value known to us, $7,000 is what we know we want to get in 6 years' time. We just have to figure out how much do we put in today to get that $7,000. We know that in 6 years, with 6% compounded semi-annually, the number of periods will be 6 times 2. Why 2? Because it's compounded semi-annually. Semi-annually means twice a year. 2 times a year I'm going to have to concern myself with interest for 6 years. So the number of periods is actually going to be 12. Now, what about this interest? The interest semi-annually is going to be 0.06 divided by 2. See, we're not multiplying this time, we're dividing because it's half the year, which means the interest is going to be 0.03. All right, what is the present value? The present value is going to be a formula very similar to what we did over here. It's going to be the future value amount of 7,000 times 1 plus the interest, which was 0.03, but the exponent this time is going to be n, the number of periods of 12, but it's negative 12 because we're going backwards in time, not forwards. All right, how does that affect our formula? Well, we are still going to have 7,000 and you're going to have to multiply 1.03 by itself 12 times, but because it's negative, that means it's inverted. It's going to be, you're going to find 1.03 is equal to 1.42576. But we divide that into 1 when we're determining the present value. So this then equals 7,000, and 1 divided by 0.142576 is 0.7013803. Okay, when we multiply those two numbers together, we find out that the present value is 4,909.67. $4,909.67. If I invest that much today for 6 years, and I compound that money at a rate of 6% semi-annually, I will end up with $7,000 at the end of the 6 years. Okay, let's try something else. We showed you over here that the interest compounding has an effect on the total interest amount you end up paying. So the interest is not really 8% annually in that case. It's some other rate. We call that the effective rate, the APY. And how do you compute what an APY is? Well, let's take a look. If we have a situation where a one-year loan is paying for $7,000 is paying interest at 12% and the compounding is quarterly. Remember, let's go and look at what this means. N is going to equal number of periods. Number of periods are 4. Interest is not 12% because it's compounding, not simple interest, it's compounding. So the interest is 12%, 0.12, divided by the number of periods, N, which is going to equal to 0.03. Right? So let's take a look and determine how much the future value of this loan is going to be. Well, it's going to be 7,000 times 1 plus the interest rate of 0.03, and the exponent is the number of periods. In this case, that's 4. All right, that amounts to 7,000 times, when you simplify the 1.03 to the power of 4, 1.12, 55088. We multiply these two together and we find out that the total is $7,878.56. That's the interest and the principal combined together. How do we compute the interest? We take off the original value, the face value of that loan of $7,000 from the total payment to see how much interest we actually paid. Subtract that, we find out we actually paid $878.56. Okay. We know that's quite a bit more than we would have paid with simple interest. So let's see what the effective rate is, the APY. We can figure that out by taking that interest amount, $878.56, and dividing that by the face value of the loan, which was $7,000. Okay, when you do that, you find out that you have 0.1255. Now we have to state that in terms of a percentage, so we move that decimal place over 2 spots, 0.55, and we add the percentage sign. And there we have it. We are paying an effective rate of 12.55% instead of 12. You can see how over a longer period of time, this could be a substantial difference than simple interest. So that's compound interest and how to compute it with a face value or a present value and a future value.